Okay, today we're learning powers of monomials. So when monomials are risen to a power. So go ahead and read that comic. It's pretty funny. So yesterday we learned about when you have same bases and you multiply or divide, then you add or subtract the exponents. So we can talk about expanding that. This 3 means there's 3 groups of these. So we're going to go ahead and write out 3 groups of these, just expanding it like we did a little bit yesterday. Okay, so then we talked about if we have numbers, we multiply those like normal. We'll put all the A's together. Oops, A. And the B's. And the C's. We could put multiplication signs in there, but we don't have to. So 5 times 5 times 5, or 5 to the third, is 125. Yesterday we talked about when you're multiplying same bases, we can add their exponents. So 2, 4, 6. Same thing, 3, 6, 9. C, 1, 2, 3. And there we have our answer. So this was kind of a long process to write it all out. I wonder if this could help us with these numbers. We went from 3 and 2 to 6, even though I wrote it wrong. We went from 3 and 3 to 9, and 3 and 1 to 3. I wonder if those are related somehow. So power of a power, something raised to a power. We can read that. We'll also read about it down here. So if you have 6 to the 4th, and then all of that to the 5th, that means that there's 5 groups of those. So if we put that 5 groups out there, then it turns into what we did yesterday, where we add all of those. Well, isn't that the same as 4 groups of 5, or 4 times 5? Sure is. So that's what we're going to do. So power to power, exponent to exponent, means multiply the little number to the little number. Usually it's written outside parentheses. So we'll practice that a little bit. That's the shortcut. We're going to prove it a little bit more right here. So we're going to apply that right here. We're going to rewrite it, expand it, and then we'll use the shortcut on the next one. So 8 to the 4th, 3 groups of 8 to the 4th. 8 to the 4th, 8 to the 4th, 8 to the 4th. Well, these are the same bases, so we just add the exponents. 4 plus 4 plus 4 is 12, so 8 to the 12th. That'd be the same as 3 times 4. 5 groups of k to the 7th. K to the 7th, k to the 7th, k to the 7th, k to the 7th, k to the 7th. Well, 7, 14, 21, 28, 35. So k to the 35th from yesterday. Same thing as if we multiplied. So now let's use that multiplication shortcut so that way we kind of eliminate that second step. So on to slide 5. It says, now let's use the multiplication shortcut. So if we're going to cut out that second step, we got to find a way to show our work. So I'm just going to show my work by doing this. I'm going to take 2 times 5 and get 2 to the 10th, because that's 2 groups of 2 to the 5th. I'd have 10 2s. W to the 24th. Oh my gosh, more than 2 exponents, we get to multiply all of them together. So this would be 2 times 3 is 6, 6 times 2 is 12, or 3 to the 12th. Awesome. So these are just as a shortcut, just multiplying. You could expand them all, no problem, but this eliminates the expanding part. So here we have the same thing, but we're going to add coefficients. So if we add coefficients, we have to remember that any factor or any base has a power of 1. So let's go down here. Here's a little hint. When multiplying exponents, you need to multiply to both variables and coefficients. So remember that the 4 right here has a hidden exponent of 1. So really this is 4 to the 1st, p to the 3rd to the 4th power. We're going to kind of distribute that 4. So 4 to the 1st times 4 is 4 to the 4th. P to the 3rd to the 4th is p to the 12th. And 4 to the 4th is, this just looks nicer if we write it out, 256. So 256 p to the 12th. The next one, we could rewrite that as negative 2 to the 1st power, m to the 7th, n to the 6th, all of that to the 5th. We're going to have 5 groups of all of these. So this is negative 2 to the 5th, m to the 7th. Oh, 7 times 5 is 35. 6 times 5 is 30, so n to the 30th. And then negative 2 to the 5th is negative 32. And then bring down my variables, and I'm done. So here I'm still multiplying, but making sure that I get it to the coefficient as well. So don't forget that hidden 1. Okay, here's a little more practice with that. So we could rewrite this as 8 to the 1st, b to the 9th, all of that squared, distribute the 2, 8 squared, b to the 18th, which ends up being 64, b to the 18th. Same thing here. Rewriting it, distributing it, get some big numbers. 6 to the 4th is 1,296. All right, last but not least, rewrite that. Distribute that. Negative 5 to the 3rd, w to the 6th, z to the 24th. This is a odd exponent, so negative 125. Bring the rest down. All right. A few more problems. Word problem here. There are two ways to find the area of a square. We have length times width or sides squared, since the length and width are the same. So this one says, the magazine offers a special service to its subscribers. If they can scan the square logo shown on the smartphone, they receive special offers from the magazine. Find the area of the logo. So area equals length times width or side squared. So I'm going to use side squared since that has an exponent. The side is 7, a to the 4th, b. Square that. Distribute that. 7 squared, a to the 8th, b squared. 49, a to the 8th, b squared, units squared, since it's a word problem and we need a label. Next one is very similar, but it's volume. Here I rewrote it. So volume of a cube is going to be length times width times height, or side cubed. So we now know the side is 6mn squared. Cube that. Give it to all of them. 6 cubed, m cubed, n to the 6th when we multiply them. 6 to the 3rd is 216. Label is units cubed. There we go. Last but not least, a couple challenge problems here. If you want to pause and try this on your own, that'd be great. But we're going to distribute the 3 first and the 5 first. So we 3 to the 3rd, x to the 12th, 2 to the 5th, x to the 20th. Now, 3 to the 3rd is 27, and same base, and then 2 to the 5th is 32. So I did my coefficients. Now my x's, I add them, so x to the 32nd. 27 times 32 is 864, x to the 32nd. Ugly. Ooh, next one. 1/3 to the 3rd, x to the 12th. Remember that 3 goes to the 1 and the 3, the numerator and denominator. 1 cubed is 1. 3 cubed is 27, x to the 12th. Awesome. And that's it.